Hello, so let's start this smallest sum contiguous subarray problem, and this is like it is a part of Kadane's algorithm basic implementation we have seen. So how we can approach this problem? So in all like smallest sum, maximum sum, in all like contiguous subarrays, we have to like in the brute force we need to have a we need to keep a consideration of all the subarrays generated, like generate all subarrays and keep track of like of minimum sum here in this case. If it will be a maximum sum problem, then we have keeping track of the maximum. So like we all know basic we all know like the basic thing for the generation of all subarrays, like let me implement for I less than n, where n will be the array size int n equal to a dot size. This is a simple problem. Like when we will solve it using the optimized approach, it will look like a much simpler than this brute one. So for int j equal to I, j less than n, j plus plus. This is like the approach for we will need to keep track of for each I, like from starting index I, particular I, we are gonna calculate the smallest contiguous subarrays for like for every I, for I equal to 0, I equal to 1, likewise. So int mini equal to int max, sorry, currently we can take it like int def, and for maxi because we need mini as the like global variable which we were going to return as answer. So yeah, what is this smallest sum? Smallest, sorry, we can like take it as sum as 0, not gonna initialize because it will not go like that much beyond, like sum plus equal to array of j. Yeah, we are adding the particular value, and then we will keep track of the maximum mini value till this particular subarrays we have generated, like for particular I and for till particular j. So like mini equal to minimum of mini comma sum. So basically we are keeping track of the minimum sum, and at last return the mini variable. It will be like n square complexity. Yeah, it is running fine, but it will give us the TLE when the constraints are large. Like for this case also, I think it will give us like TLE, and also the approach we need to implement is like have to be a complexity of big of n. So what we can do, like we have seen in the, let me remove this. Yeah, like we have seen this normal cadence pattern where we need to have particular, like we have particular boilerplate given and we need to write code based on that. So before implementing we need to understand what we are doing. Like suppose if we were taken 3 and initially sum will be 0, so sum 0 plus 3 it will be 3. So when you add a negative value, overall it was decreasing, but why to add the positive value in the answer? It will overall increase the answer and we need the smallest one. So basically whenever we have got a positive value, basically reset the sum to 0. So it will be like gather all the negative elements, or like gather the smallest continuous array. And one more thing, like suppose you have got sum as 3, so you have reduced it to 0, but once you got minus 4, yeah, minus 4 is in track, and after that minus 4 plus 2, it will be like minus 2. Still we are having a minus value, so we gonna take this in consideration. Since if we don't consider, we will have like minimum as minus 3 minus 1 minus 4, but that's not correct because minus 4 plus minus plus 2 equal to minus 2 plus minus 4 means minus 6. So this will be like correct answer. So if only we have like value greater than 0, then only reset the sum to 0, otherwise don't. So let's implement the solution. So yeah, so let's start the implementation for this Kadane approach for int I equal to 0, I less than n, I plus plus. Sorry, we need to keep track of the int min sum, int max, as well as for current sum tracking int sum equal to 0. Yeah, so let's start. Basically we are gonna add each element to the sum as we start traversing. Sum plus equal to array of I means a of I. After that, what we basically do in Kadane, like if sum, sorry, yeah, if sum is greater than max sum. So this was the condition when we have asked to like solve the maximum sum contiguous array. But here we need to keep track of the minimum. So if sum is less than mm, min sum, then we are gonna update our min sum with the current sum with the sum. Also, what we have discussed, like handling of the positive case, like if ever we have value sum greater than 0, then we basically switch it or reset it to 0. So for that, if sum greater than 0, then basically reset this sum to 0. Let's try submitting it. Yeah, it's running fine. Let's submit it. And here we are basically solving the problem in big O of an app, big O of n complexity. So yeah, it is much better than n square. And you also think like here the implementation is slight easy. Like we basically need to handle this part explicitly. Otherwise, it will be like simple Kadane pattern based. So thank you. And in the next video, I will like come with the another Kadane based pattern problem.